these are similar to the other questions that we've been doing where they tell you one trigonometric function value and ask you then to find the other 6, okay? Now, here, instead of finding the other 6, they ask you to find sine of 2x instead, cosine 2x. But in the event of finding those, you have to find sine of x and cosine of x. So it's a very similar process as what we've seen in the past with questions like this. Now, they tell us that tangent is negative 1/6. So if tangent is negative, what 2 quadrants is tangent negative in? 2 and 4. Okay? So we could be residing, our angle that they're calling x could be in either of those 2 quadrants, which could create an issue for us in regards to finding sine of 2x, cosine of 2x, tangent 2x. Okay? We could ultimately say we have 2 different sets of solutions. So what they then do is tell you this criteria as well, which says cosine is positive. What 2 quadrants is cosine positive? 1 and 4. So if cosine is positive in 1 and 4, so now which quadrant then is tangent negative and cosine positive? It's 4th quadrant, right? So what they're doing there with that extra information, which a lot of people in the past would neglect this and just say, nah, I don't know what that really means. What they're telling me there, I'll just draw this stuff in the 1st quadrant. And what happens is you get the right values. You're just going to get the wrong signs, S-I-G-N, when you do that. Okay? So we need to be in the 4th quadrant here. And the x that they're talking about then, remember, is the x from standard position. That would be the angle that we're talking about. But this triangle is going to lead us to all of that necessary information. So when I say tangent x is equal to negative 1/6, negative 1/6 is opposite over adjacent, right? Which one of those is going to carry the negative with it? The 1. Okay? Pythagorean theorem is going to tell you that this distance right here is what? Radical 37. We're square 6, square negative 1, add those together, I get 37, and then take square root. Is that all right? So now you have the structure, you have the picture to find all 6 trig functions, sine, cosine, secant, cosecant, cotangent, tangent. But then you also have, because of being able to find those other trig functions, all 6 of them, you can now find all your sine double angles, all your cosine double angles, tangent double angles, half angles if we wanted to, because all of those formulas are written in terms of the original 6, right? And really, they're in terms of the original 3, sine, cosine, and tangent. So, if we want sine of 2x, we can't just use this picture and our knowledge about x to tell us something about 2x, because I don't know what x really is. But we use a formula that says the sine of 2x breaks down to 2 sine of x times cosine of x. That's an identity. And why is that useful? Because now everything on this right-hand side is in terms of 1x, and that's what our picture is in terms of, right? Okay. So, what is the sine of x from our picture? Okay. And what is the cosine of x? 6 over radical 37, right? And then if I multiply all that together, I get negative 12 over 37. A really nice, clean fraction. Okay, now if I want to find cosine of 2x, okay, a couple different formulas you can use here. You can go cosine squared x minus sine squared x. You can go 1 minus 2 sine squared x, or you can go 2 cosine squared x minus 1. Those are your 3 different variations of the cosine double angle formula. Doesn't matter which one you use. Which one you guys want to use? That one? Okay. So I'm going to go 1 minus 2. What's your sign of x then? Negative 1 over radical 37. And we'll square that. So then when I apply that, so it's going to be 1 minus, it'll be 2, 1 over 37. Good. So we got now 37 over 37. That's my 1. Minus 2 over 37. What's that give me? 35 over 37. And that then is the cosine double angle. You could have done the same thing using that formula, or gotten the same thing using that one. It's just that your algebra is going to be a little bit different because your inputs are a little bit different. Okay? Yes. So the tangent formula, okay, you've got some options here now. When we get to tangent, tangent of 2x is equal to 2 tangent of 1x divided by 1 minus tangent squared x. Okay? Now, perhaps because of how the problem started, like, so if they gave me this to begin with, they gave me tangent of x equals negative 1/6. If this was the only question being asked, find tangent of 2x, that formula makes the most sense to use, right? Because I could just say, okay, well, tangent of x was negative 1/6, and plug that stuff in. So now I get negative 2/6 over, now this will turn into 1 over 36, right? So I have 36 over 36 minus 1/36. So it turns into negative 2/6 over 35, 36, multiplied by reciprocal, 36 35ths, cancel, cancel, gives me 6. And I get negative 12 35ths if I use my formula. Okay? Now what Anthony is saying is, can't I use the relationship that says that tangent of 2x is the same thing as sine of 2x divided by cosine of 2x, correct? What's the sine of 2x? We already did that, right? Negative 12 37ths. What was cosine of 2x? 35 37ths. What's going to happen with the 37ths? You're left with, which is exactly the same thing we got when we used the formula, right? Okay. Now, I think that there's a lot of work there. I don't think it's beyond us, but I think once you have a lot of work and it's a complex problem, I like to have the gratification that I've done it right. So I want to grab my calculator and just kind of process this a little bit. Okay. They tell me that tangent of, I'm just going to use A instead of X so it doesn't graph it. They tell me the tangent of my angle is equal to negative 1/6. Okay? That is a implicit way of telling me what the angle is, isn't it? Can't I take the tangent inverse of that side and the tangent inverse of that side and get what A is? Okay, so I'm going to take arc tangent of negative 1/6. Okay, now this is in radians, so let's change over to degrees. It gives me that. Okay, so now here's the thing, and that is a fourth angle quadrant, or fourth quadrant angle. But it's not how we like to deal with it. Okay, what should I do with that number? Because if I take, I'm going to add 362. I'm going to make it a positive angle. Okay, now you could deal with it. We'll see maybe here in a moment. If I double that, can I still generate the same results that we have here on our actual problem that we worked out? But I'm going to add 360 to that just so that I can visually argue that does make sense as being a fourth angle quadrant, right? So I messed that up again. Fourth quadrant angle. We call that? I'm going to call that T. Okay. Now, 2T would be the angle that they're asking information about. So this is the angle they started you with right here in the problem. This is the angle they're asking questions about. So if I take sine of that 701, I get that number right there. Okay? Well, if I take negative 12 divided by 37, is that the same number? Okay? So we're seeing that we do have the correct value for our sine of 2x, or 2 times our angle. If they wanted cosine, okay, we get 0.9459. Okay? Well, we said it was positive 35 divided by 37, and that turns out to be the same number, right? And if we want a tangent of 2t, we get that, which we said was going to be negative 12 over 37, which you get the same decimal in, right? 35, I'm sorry, 35. So there's the same decimal. Does that make sense, everybody? Does the same thing happen if we don't add 360 to this? Yes, it does. Okay, because the idea, okay, well, if I have negative 18, okay, negative 18 plus then 360 will still be the same as that 7. It'll be a coterminal angle with that 701. Does that make sense? It works. So, all right, can we do that? All right, so the next question is exactly the same. But we're working with the different formulas now. Now working with the half angle formulas. They give me sine of x equals 24/25. What quadrant is that telling you you're going to need to operate in? First quadrant. So sine, that's 24. That's 25. This would be the angle x that they're talking about. What would this distance here be? 7. Okay. 625 when I square that. 576 when I square that. When I subtract those, I get 49. Square root of 49 and a 7. So now when we go ahead and figure out our total angle measure, before we're done here, we're going to check this. If this angle that they started with was between 0 and 90, you just think about this. If I go 0 to 90, then when I make this half that, when we work with linear inequalities, which is what we've got here, we do that to all three parts, right? Doesn't that give me 0 is less than x over 2 is less than 45? So the theta that we're talking about when we're done here is going to be between 0 and 45. When we grab our calculator and check, we should be able to see that confirmation. When we deal with sine of a half angle, it's going to be plus or minus, and then it's 1 minus cosine x over 2. Now, because I'm in the first quadrant, that tells me how to choose the plus or minus. The y value in the first quadrant is positive. Okay, so this half angle that I'm going to come up with here in a little bit is going to have a positive y value, so I choose the positive one. Is that okay with everybody? All right, so now 1 minus cosine. What's cosine here? 7/25 all over then 2, right? I think it's appropriate. You could leave it that way, but my hopes are you see that as we go further, there's great reason why not to leave it this way. Okay, I make that 25/25, right? So 18/25 all over 2 underneath my radical, right? Multiplied by the reciprocal of that 2, and the 2 and the 18 will cancel, and I get 9/25 underneath. And what's that turn into? 3/5, right? Is that a much cleaner result than leaving it as that? And that won't always happen, but that's a purpose. That's a reason why we like to try to run through that, combining fractions here, get rid of the compound fraction, all that kind of stuff, because something nice might materialize. Cosine of x over 2, same formula, but what changes in this formula here? Yeah, that minus turns into a plus. So 1 plus cosine of x over 2. So now we'll have cosine, again, is 7/25. So I have 1 plus 7/25 all over 2. So now 25, so that'll be what, 32 25ths all over 2. When I multiply by that reciprocal of 2, I'm going to get 16 25ths. So are we okay with that? Me skipping that step right there? And that's going to cancel 16 times 1, 25 times 1. Yeah. So what's that reduce to? 4/5. Okay. Yes. Yes. So now just be careful on how you. So Jim is saying, can't I use this relationship? Knowing now that cosine, or sorry, we found sine, right? Knowing that sine is 3/5 right there, can we do this and solve for cosine, right? Remember that? That was like the first problem we did in chapter 7, I think. Okay? Or chapter 6. Say again. Right, so we took square root of radical 9/25. So give me 3/5. Now, here's the only thing, and I just said be careful, because I use theta here, right? What are we really using here? And technically, like if I'm going through the word, it doesn't matter. But I just want to make sure that I use the same argument here that I'm using there in order for that to work. That's a good idea. That's perfectly fine. If you remember I think we went through the proof of this briefly with you guys. If you want to use the tangent half angle formula, it's sine of u over, where'd it go? These are half, double. There's sine of u over 1 plus cosine of u, or 1 minus cosine of u over sine of u. Either one of those is fine, but the amount of substitution that we have to do there is probably more work than just taking the knowledge that we know we have sine and cosine of my half angles already found. Okay, was this the sine? That's the sine and that's the cosine. So how does the tangent of the double angle relate? It's the sine, or sorry, tangent of the half angle. It's the sine of the half angle divided by the cosine of the half angle, right? So can we take 3/5 divided by 4/5 and get 3/4? And that should allow us, once we have those, and because those work out to be really nice numbers, we can see in Desmos really easily, we can actually get Desmos to replicate the actual fraction result. We knew that they said sine was 24/25. Sine of x equals 24/25. So I'm going to go arc sine of 24/25. So that's the full-sized angle. That's x. Okay? But didn't we take, and I'm going to call it t just because of the graphing here. Didn't we say that when we take half of it, we should get, because it started between 0 and 90, when I take half of it, I should get an answer between 0 and 45? That's between 0 and 45, right? So now they're saying, well, if that's, I'm just going to call this A for easier input down here. If I go sine of A now, is that 3/5 right there? If I toggle the fraction thing, you get the actual fraction 3/5, right? Cosine 4/5. Tangent 3/4. My hope is, and that's, do I have to check these? No. But if you understand how to check this and actually do this, I think it gives you more insight to the actual process here and being able to be more efficient and really understand the dynamics of the problem, what's going on. Okay. We'll stop there. There's no new homework or anything like that. Keep plugging away at that 7.2 and 7.3 assignment that's open. Those are questions that are from those two sections. My hope on Monday is that we hit the ground running with equations, solving equations, getting back into what we did at the end of the period yesterday. That's all I got for you.